In this video, we will be talking about redox reactions. The learning objective for this video is to describe oxidation-reduction reactions. Oxidation and reduction reactions are called redox reactions for short. Oxidation is the loss of electrons, and so that spells out oil as an acronym, and so you can help remember that oxidation is lost through that. Then we have reduction is the gain of electrons, and so that spells Rig. And so you can help remember that oxidation is loss, reduction is gain through saying oil rig. Or you can remember it by saying Leo the lion says grr, where loss electrons is oxidation and gain electrons is reduction. Now, it might seem a little backwards at first to say that reduction is gain, because reduction itself means go down. And so we have to remember that electrons are negative. And so if we gain a negative, we go down in charge. And so if we gain electrons, then our charge goes down. And if we lose electrons, then our charge goes up. And so what's going down, why it's called reduction, is the charge. Really, it's the oxidation state or oxidation number, but we'll go into determining what that means very shortly in the next video. But if we look at how the charge changes for now, we can determine what's being oxidized and what's being reduced. Oxidation and reduction always have to happen together because electrons are matter too, and we can't just lose electrons without them being gained somewhere else. Here's a note about states of matter for a redox reaction. Here we can see that we have Zn solid. Zn here is neutral. There is no charge written on it, and so it's neutral. And that means it's going to be whatever state of matter it normally is at room temperature. And so that is solid for most metals and other substances. Then, once we put it into that's our zinc strip here, once we put it into aqueous copper ion solutions, then the electrons exchange between the copper and the zinc, and the copper becomes solid. And that plate's on here. And so the neutral ones are always solid, and the charged ones are aqueous. So the charged ones are aqueous and the neutral ones are solid. You can see here that once this copper ion comes in, it exchanges electrons with the zinc, and then the zinc leaves as an ion and the copper deposits on the surface. As I said before, oxidation and reduction always happen together. If we look at the zinc's charge here, zinc goes from being neutral to being 2 positive. And so this is going up. That is my oxidation reaction. This is what's known as a half reaction. The overall equation can be split in 2 different half reactions to show how many electrons are being lost or gained. And so you will always have an oxidation half and a reduction half, and they will add together to give you the overall. We can also tell that this is an oxidation half reaction because electrons are lost. This is the reduction half reaction because we have copper 2+ here getting changed into copper neutral. And so that's going down. And so that's being reduction. This is also electrons on the product, on the reactant side, which means the electrons are being gained. The number of electrons lost has to equal the number of electrons gained because electrons matter. And so in the overall equation, all of the electrons will cancel out. Here's a practice problem for you. I want you to go ahead and pause the video and try to identify whether you are looking at something being oxidized or reduced. Unpause the video when you're ready to check your answers. All right, let's go over this. So Cl2 and 2 minus, we can see that this is being gained because it's on the reactant side. We can also look at the charge and see it's going down from a 0 to -1. And so those are two clues that it's being reduced. Now we have iron 2 plus and iron 3 plus, and we can see that its charge is going up, and we are losing an electron. Since we are losing an electron and our charge is going up, this is oxidation. These next ones are not balanced, meaning there's no electrons in the equation, but we can see that the charge on the sodium is going from +1 to 0, and so that is going down. It's not going down. It is going down. Going down is reduction. Now we have this one going from a 2 minus to a 0. That's going up. And so this one is oxidation. Some additional vocabulary to you. For the previous problem, we were identifying whether a reactant was oxidized or whether it was reduced. If something is getting reduced, it's gaining electrons from something else. That means it's taking electrons away from something else. And in turn, that means that something else is getting oxidized. So if something is getting reduced, it must be taking an electron from something else in order to get reduced. That means that if something ends up being reduced, it is the oxidizing agent. In other words, the oxidizing agent causes oxidation of something else. The reducing agent causes reduction of something else. Because it's causing reduction, it's giving up electrons, and so it will end up getting oxidized. Previously, we talked about simple reaction patterns, like double displacement, single displacement, and so forth. In our double displacement patterns, nothing ever changed charge. And in our redox reactions, electrons are always being exchanged, which means that our charges are changing. This means that double displacement reactions are never redox reactions. Here's another way of overlapping those categories. So for our simple reaction patterns, our acid-base neutralization reactions and precipitation reactions will always follow our double displacement reaction pattern. Single displacement are always redox. Combination and decomposition are always nothing. I mean, they could be redox, they could be not redox. So combination and decomposition are often redox, but not always. The only things that you can count on are single displacement are always redox, combustion reactions are always redox, and acid-base neutralization and precipitation are always double displacement. Not all reactions that occur in life fall into these nice little categories, but we will be focusing on these nice little categories. You can use that mutually exclusive concept in order to identify which of the following reactions is an oxidation-reduction reaction. Go ahead and pause the video in order to figure out which reaction is the redox reaction. Unpause the video when you are ready to check your work. Okay, so our redox reaction here is option C, because this is the only one that is a single displacement. All of the others follow our double displacement reaction pattern. Single displacement reactions are always redox, and double displacement reactions are not.